Hi guys, thank you so much for tuning in. Now we're going to learn on how to identify this one here, 0.12 recurring. Both of them are recurring, which means we are having a situation where it's 0.12121212, right? Remember the previous video, I explained to you how do you identify this 0.9 recurring being equals to 1, right? So normally the question can come as that, or it can just tell you that please write this 0.9 recurring as a fraction, as a common fraction, which in this case it will give you 1 in this case, right? 0.999999 will just give you 1. Now let's solve this problem now. If you haven't watched that video, please look in the description below. I have explained on how to identify 0.9 recurring as being equals to 1, right? Without rounding off, because some of you are just going to round off and say, oh, you're done. So anyways, let's solve this problem here. How do you identify this problem of 0.12 recurring, right? Both 1 and 2 are recurring, are repeating, right? So what we do is this. Obviously the question will come out as write it in a fraction form, in a common fraction form. Common fraction. So how do you write down 0.1212121212 as a fraction? So the first thing you're going to do is this, right? So I'm just gonna identify my series. That's the first thing you have to do. So for you to do that, let's first write this 0.121212. Obviously, you don't have to continue. I'm just continuing. 1, 2. You first have to identify the first 3 terms of your series, right? The first term should be these 2, right? Those are the 2 terms that are recurring, 1, 2. Then the next term would also be 1, 2. Third term would be 1, 2, 1, 2, just like that. So this would be my first term, and this would be my second term, and this would be my third term. But we have to identify them in a fraction form, right? How do you identify the 0.12 as a fraction form? You have 0.12. You're going to remove this comma here up until it is behind 1, 2. How many times did you do that? We did it 2 times, right? So meaning we multiply by 100, which will give us 12, right? So the opposite of multiplication is division. So it's going to be 12 over 100, right? So that is the first term of the series, right? You can punch this 12 over 100, you're going to get 0.12, right? So now let's identify the second term here, this number 2 here, which is, now that you are done finding the first term, you don't have to include these 2 terms here. It's actually going to be 2 zeros now. It's going to be 0 and a 0 and then 1, 2, right? So how do you now write that down in a fraction form? 0.0012. So we're just going to move this dot up until it is behind the numbers 1 and 2, right? It has to be just behind them, actually behind 2, right? So it's going to be 1, 2, 3, 4. So we did that 4 times. What does that mean? We used 4 zeros. We multiplied by 4 zeros. A 1 with 4 zeros. So it's multiplied by 1 with 4 zeros. 1, 2, 3, 4. What is that? 10,000, right? So it's going to be 12 over 1 and 4 zeros, right? Which is 10,000. And then now we are done with these numbers. Now we want to identify this one here in a fraction form. So meaning here it's going to be 0 and here it's going to be 0. So you'll have 0.000012. So we need to write this in a fraction form. How do you do that? You move this dot up until it is behind the 2 numbers, actually behind 2. So it's going to be 1, 2, 3, 4, 5, 6. So we did 6 zeros, right? So basically you're saying you multiply by 6 zeros. 1, 2, 3, 4, 5, 6. Okay, oops. 0.00. Let me write it properly. Multiply by 6 zeros. So it's going to be 1 and 6 zeros. 1, 2, 3, 4, 5, 6, right? Which is 10 to the power of 6, right? So it's going to be 12 over 1, let me first remove this here, multiplied by, so it's actually 10 to the power of 6. You can either write 6 zeros or just say 10 to the power of 6. So I'm just going to say 0, 0, 0. That's 3 zeros. 1, 2, 3, another 3 zeros. So now you've identified your series of the sequence. You can now write down the 0.12 recurring as a fraction. Now it's simpler. The method that we use is a sum to infinity. So we're going to use the formula of a sum to infinity, which is equals to a over 1 minus r. So this is a. I know it looks like 9, but it's actually a. So our a value is our first term of the series, right, which is 12 over 100, right, this one here. And then our r is our common ratio, which you're going to say term 2 divided by term number 1 is equal to term number 3 divided by term number 2. So this would be your term number 3, this would be your term number 2, this would be your term number 1. So divide that out, you should get your r being equals to 1 over 100, right? So once you found your a value from the series and your r by dividing as I instructed or as I guided, then you will just plug that in. So plug it in your formula of a. So in a, you're just going to substitute 12 over 100, right, and divide by 1 minus our r, 1 over 100, right, and then punch that in your calculator, your sum to infinity, and you should get your answer being equals to 4 over 33. How do you see that you are correct? Just punch that 4 over 33 and see if you're not going to get 0.121212, recurring. You have to get that. If the answer is not that, which means you've done a mistake in your problem, right? So now let me also explain this other one that I indicated in the previous video that you must do. 0.6 recurring. I think we now know how to do it, right? We're just going to say 0.6666666. That's how it looks, right? 0.666. But we want the first 3 terms. So it's going to be, this would be our first term, this would be our second term, this would be our third term, right? How do you find the first term? It's 0.6, right? Multiplied by 10. Now you know how you do it, right? Which it's going to be 6, right? But we want it in fraction form, so it's going to be 6 over 10. So 6 over 10 plus, why did I say 6 over 10? I mean, the opposite of multiplication is division. That's how I got that. Now we scratch it out. We want this 6 now, so it's going to be 0.06 because this 6 is gone, right? How do you write this in fraction form? Multiplied by 100. So it's going to be 6 over 100 plus, I guess now you know how it's going to look. It's going to be 6 over 1,000, right? Then you have your sequence now. So your a value is 6 over 10 plus your why am I saying plus? Jeez. So your r is going to be term number 2 over term number 1 is equal to term number 3 over term number 2, right? So which means your r will be 1 over 10. Just punch that out in your calculator, because this would be your term number 1, this would be your term number 2, this would be your term 3, right? Find that out, and now you can use your formula for sum to infinity. Sum to infinity is equals to a over 1 minus r, right? Which is equals to our a value 6 over 10 divided by 1 minus our r, which is 1 over 10, right? And then your answer to this one would be 2 over 3. So punch that 2 over 3. Once you found the answer 2 over 3, punch it out and see if you're not going to get 0.6 recurring. You're definitely going to get that, right? So please, that's how you do this problem. Now I want you guys to try this one out. Oops, I want you guys to try this one. It's a very interesting one also. It's 4.18, so these two are recurring. How do you solve this one? How do you write this in a fraction form? Please try it out. I'm going to explain it in another video. Check out the description in the comments. That's where you'll find the solution to this problem. Otherwise, thank you so much for watching. Shop. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them down in the comment section below. Otherwise, please subscribe to the channel and don't forget to click that bell button.